Super Smash Bros. Brawl is a fast-paced fighting game featuring characters from a variety of other video game franchises. The aim of the game is to deal some serious damage to your opponents and knock them off the map. Brawl's ridiculous concept seems to have influenced its wonky physics system, which had us scratching our heads at its weird incongruities.
In order to investigate the physics of the game, we needed to establish some form of measurement. We eventually came across the height for one of the characters, Donkey Kong, online. We found out that he was 6 foot 3 inches tall. We converted this to meters and declared the height of one Donkey Kong 1.905 meters so that we would be able to use this height to measure lengths in the game. We started off with analyzing the gravity in the game. We found quickly that the characters were not accelerating while they were falling downwards. They were falling at a constant velocity. We found this by utilizing the donkometer that we had established at the beginning. We used the donkometer to measure the height at which a character was falling from, which in this case was 4.5 donkometers or 8.57 meters. After getting this height, we timed how long it took a character to fall halfway down with an average of 0.92 meters per second, and then all the way to the ground, with an average of 1.84 meters per second, which is exactly double that of the previous number calculated. We were able to observe and record the time with the video editing software in order to reduce the amount of error that we would experience timing it ourselves. We concluded that, in this game, characters falling reach terminal velocity almost as soon as they start falling. This means that the characters are reaching their maximum falling velocity pretty much instantly. This was such an odd concept to work with that we decided that we needed to further investigate this. Terminal velocity implies that the amount of drag is equal to the amount of force pulling you downwards, so that your net force is 0 and that you do not accelerate. Because there was some kind of resistance affecting the characters while falling, we decided to see if this resistance, which we believed to be air resistance, affected things moving horizontally. In order to test this, we used a game mode that allowed us to measure the distance that a sandbag traveled. We were able to determine that the sandbag did not accelerate, positively or negatively, in the horizontal direction. We were able to determine this by using a video editing program, just like the previous experiment, to observe the time at different distance intervals, and then we calculated the velocities for each interval in order to see if the sandbag was accelerating or not. The data ranged from 51.8 meters per second to 53.6 meters per second, and it varied at different intervals. So it was assumed that the data did not represent exactly what was happening in the game. However, the numbers were so close together that the sandbag was, according to the physics in the game that we had observed, moving at a constant velocity, and that there were inaccuracies with our method of recording time.
The next phenomenon we decided to investigate was the sheer force of Captain Falcon's legendary Falcon Punch. A Falcon Punch appears to send Sonic flying 3.47 donkometers in the horizontal direction before he hits the ground. It takes approximately 0.7 seconds for Sonic to fall. Knowing that, we're able to calculate the force of Captain Falcon's punch by dividing the distance by time to get velocity, multiplying by Sonic's mass, 35 kilograms, and dividing by time. And the result is a rather disappointing 472 newtons. To put that in perspective, Olympic boxers are recorded at punching with a force of 1,989.15 newtons. If we were to consider the vertical component of Sonic's movement, that would increase the force of the punch a bit, but it would still be a far cry from the punching force of a human boxer. To the game's credit, 472 newtons is a fairly realistic punching force for an average person, but of all the words you could use to describe Captain Falcon, I would not expect average to be one of them. But of course, no scientific analysis of a Smash Bros. Game is complete without a discussion about one of its chief game mechanics, percent damage. Characters receive more of the percent when they're hurt and become more vulnerable to being shot off the screen. Now, right off the bat, the use of a percent sign here is baffling, especially considering the percent damage can rise well above 100. but concentrating on that would be doing this mechanic a disservice. The real question is, how does getting hurt make characters fly farther? Initially, we hypothesized the percent damage affected the mass of the character, but since percent damage has no relationship to terminal velocity, this seems unlikely. This is an aspect of the physics system that really does not seem to have any basis in reality, so far as we can tell.